Okay, hi Pawan, can you hear me? Okay, guys, I'm back. So yeah, coming back to this again, perfectly done for the next IP. I mean, for the next binary to decimal conversion. I hope everyone has got the same answer, 90. If not, again, as I've mentioned, could be as just a minor mathematical error here or there. Okay, but I hope the concept is clear for everyone. How do you convert it? Multiply the lower number with the top one and add it up till the last. Now, with the same method, guys, you can try to understand the range of IP addresses as well. So in order to get the first IP, all you have to do is put all zeros everywhere. So in the first octet, second octet, third octet, and the fourth octet as well. When you put all zeros, you get the first IP as 0000. And if you want to get the last IP, the maximum value is putting all ones everywhere. So when you put all ones now, 2 power 0 into 1, plus 2 power 1 into 1, plus 2 power 2 into 1, plus 2 power 3 into 1, all the way up to 2 power 7 into 1. So that would be 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. And if you add it up and calculate the value, you get the number 255. So the last IP in the IPv4 range is 255.255.255.255. You logically know now why it is only maximum up to 255 and not more than that, because you only have 8 bits each in every octet, and that 8 bits, when you assign the value 1 to each of them, the maximum number you can get is 255 from the conversion. So you'll never have a number or an IP address in the negatives below 0 or in the positive numbers above 255. Okay, whatever ranges, this is the first IP and this is the last IP. Now we know this is the first one and the last one. What about the IPs in between? What is the sequence of IPs? Okay, how do they transgress or progress or increment one after the other? So there are two simple rules for that, guys. Rule number one is always start with the rightmost value. So if this is my first IP 0000, only concentrate on the left side values, guys. Ignore the right side ones. I'll explain this later. Okay, just for an example. So if this is my first IP 0000, next IP is 0001. Always start with the rightmost value. So this increments by 1. So then 0002, next 3, next 4, next 5, next 6. This goes on all the way up to 255. Okay. After 255, can I have a value like 000256? Is this possible? Anyone? Definitely not. Okay, so after, yes. So after 255, now once you reach the maximum value there, rule number 2 applies. So only after the rightmost octet has been, yeah. So Rishi, are you there? Are you asking me a question? Sure, thank you. Right. So only after the rightmost octet has been completely filled, then you go to the next value. So this next octet, 0 changes to 1 or increments by 1. And then the rightmost octet again resets back to 0. So it cycles back to 0. And this 0 now changes to 1. Now, don't directly jump from 0010 to 0020 again. That is again wrong. Okay. Rule number 1, always start with the rightmost value. So after 0010, you have 1 1, then 1 2, then 1 3, then 1 4. Goes on all the way up to 1 255. Okay. After 1 255, now this is completely filled again. So this 1 increments to 2, and this 255 becomes 0 again. I hope you're following along, guys. I hope this is clear. The repetition or the cycle. So after that, 2021, 2223 goes up to 2255. Then 303132 up to 3255. Then 40. Like that, the cycle repeats again and again and again. Somewhere you'll have 2550, 2551, 2552, 2553, 255, 255. Now both these octets are filled. So once both these octets are filled, then this 0 now changes to 1. Okay, and all these 255s recycle back to 0 0. So you have again 100, 101, 102, 103 up to 10255. Again, this 255 becomes 0 and this 0 changes to 1. So whatever cycle repeated from 0000 to 00255 same cycle repeats again from 0100 to 1255255. saying again from 200 to 225.255. Finally, similarly from 0255, where is that? Yeah, here 025500 to 0255.255.255, same cycle. Again, now last octet. Now once these three are completely filled, this 0 now changes to 1. And similarly, whatever repeated from 0000 to 0255.255.255, same repeats from 1000 to 1255.255.255. Same 2000 to 2255.255.255. Last finally from 255000 to 255.255.255.255. That's how you're going from the first IP till the last IP. Again, this is again all of this I'm explaining you just so that you have a number of total IP addresses, guys. Now from the first IP till the last IP, if you wanted to calculate the total number of IPs, all you have to do is multiply 2 to the power 4. I mean 255 to the power 4, because each octet is cycling 255 times. So the total number of IPs would be 255 into 255 into 255 into 255. And if you calculate that number, you're going to get a total of 4.3 billion IP addresses in the IPv4 range. Okay. Now my question to you guys is, in today's world, if each person got a singular IP from the IPv4 range, are these IP addresses sufficient for us? 4.3 billion IP addresses. Definitely not, because the population itself today is around 8 billion people and you only have 4.3 billion IPs. So again, if each person got a singular IP uniquely, 4.3 billion IPs are nowhere sufficient. You're still falling short by 3.7 billion IPs, even more. Okay, so that is why again each person could be using multiple devices as well again. Okay, so that is why to overcome that they came up with two solutions. Solution number one is called as NAT, network address translation. So with this technology, they try to divide these 4.3 billion IPs into 5 classes and more importantly, 2 important categories. Okay, so there's something called as public IPs and private IPs. Okay, so again, to define these out, public IPs are the IPs present with your ISP. ISP stands for Internet Service Provider. The person who provides you the service of internet is called an ISP. Airtel, Idea, Tata Docomo, Act Hibernate, all these people are ISPs. So these people contain the public IPs, and these public IPs are used for accessing the internet. Okay, if you want to connect to a public domain or any website, that needs the public internet IP. Okay, and on the other hand, you have something called as private IPs. These IPs are used in your local network, in the intranet. So in your home, you might have a Wi-Fi router. To that Wi-Fi router, you're connecting multiple other devices, your mobile phone, your laptop, your smart TV, your smartwatch, and so on. These individual devices in your local intranet network get a private IP. Okay, and private IPs, guys, can be repeated in different networks. What I mean by that is, if I just draw this out, 1 second. So let's assume this is my router here on one side. Yeah, here. And to my router, I have multiple devices connected. I have my laptop, I have my smart TV, I have my phone, I have my smartwatch, and so on. So each of these devices is connected to my router, and they individually get something called as a private IP. Okay, so this could be something like, let's say, 192.168.0.1. Oh no, 0.2. This is 192.168.0.3. This is 0.4, and this is 0.5. Okay, ignore what this IP is, guys. What is this 192.168, or why I specifically selected that? Okay, but for now, let's assume these are the private IPs for them. Your router also gets an IP, which is 0.1, the first IP in the network. Okay, and to your router, if you carefully observe, there's always an external wire connected to it from outside the house. Okay, that is nothing but the public IP provided to it. Okay, so you have the ISP here, Internet Service Provider, and from the ISP you get a LAN cable. Okay, and this LAN cable is what is providing you the public IP. So let's assume this is something like 1.2. Let me change the color. 1.2.3.4. Okay, so what you see on the left side, guys, these are my private IPs here. Okay, So on the left side, you have the private IPs. And what you see here on the right side, this is my public IP. Okay. And a router acts as a gateway between two different networks. Now, similarly, you could have your house as well on the other end, which has a router of your own. Let's assume this is your house here. Again, to your house, you have multiple devices connected again. Okay, with a router. So these devices also get a private IP. Oh, 1 second, guys. Don't worry about that. Okay. And now what is unique to both of us is going to be our public IPs, guys. So I have a public IP again. Your house also gets a public IP from the ISP. This could be something like 2.3.4.5 now. Okay. And these local devices now can get the same private IP. So this could also be 192.168.0.2. Okay, then you can have 0.3 here and 0.4 here. Now, if you carefully observe, I have the same private IPs on this in your network and the same private IPs in my network as well. But what is unique to both of us is our public IPs. Okay, so when these devices want to communicate with the internet, they will always use their unique public IP. And when my devices want to communicate with the internet, they will use the unique public IP assigned to them. So in that matter, in this fashion, with the NAT technology, NAT, network address translation, you can repeat the private IPs as many times as you want infinitely. Okay, so that is why in today's world, still IPv4 addresses are in use. Okay, because whatever private IPs are there, you can use them as many times as you want. They will go extinguished when all the public IPs are used up. Okay, so even that is happening soon, guys. So once the public IPs are gone, you won't have any more IPv4 addresses to use. And that is why they also came up with another solution, which is IPv6 addresses, another much advanced version of IP addresses. And it's a 128-bit address. IPv4 is just 32 bits. IPv6 is 4 times the size, 128 bits. Okay. So is this clear, guys? The network address translation, the public IP, the private IP part. Any questions or doubts up to this part here? Anyone? Yeah, I'll be sharing the recordings as well. As soon as this class ends, I'm gonna be taking up I'll take all your email addresses first, and on the email I'll be sharing this recording, guys. Okay, right. Any questions or doubts, guys, up to this part? Anubhav. Yeah, sir. Yeah, sorry, I can hear you. Oh, nothing. Let me give a very quick recap. Yeah, sure. Let me give a very quick recap for that. Let me clear these drawings first. Again, guys, I'm going to clear the drawings. You'll be getting them in the recording anyhow. So what we discussed was basically on IP addresses. Sir, I'm sorry, I forgot your name. Sorry, yeah. So what we discussed was about IP addresses. So when you have a network is nothing but a collection of devices. So in your home, you have a Wi-Fi router. To that Wi-Fi router, you're connecting multiple devices. How are they communicating with one another? They're communicating through their identity called as an IP address. And what we use today is IPv4 addresses, IP version 4. This is basically a binary address. Binary in the sense it contains numbers from 0 to 1. That's it, two numbers. And it's a 32-bit address. 32 in the sense it has 32 zeros and ones. Okay. Now this is binary language. What we have seen is how to convert this binary to decimal language as well. You can go through the recording for that, Soroshi. Okay, quite a lengthy procedure, but easy to follow. You've been here? Yeah, nothing. Just before that, I just explained what IP addresses look like, what are the properties of IP addresses. It has 32 bits for, again, each IP is separated in 4 equal parts called as an octet, and each octet is separated by a dot. Okay, that's all I've explained. After that, I explained how to convert binary to decimal numbers, then a range of IP addresses. What's the first IP? What's the last IP? What is the sequence of IPs? Okay, and after that, we talked about what are the different types of IPs, public and private. Okay, now if I show this practically, guys, if you want to check your public IP, okay, just go to your browser, and in the browser, search for what is my IP. and that is going to show you your exact public IP. So right now, this is my, oh, what is my IP? Sorry, not your IP, my IP. And you can see this shows me a public IP address 49.204.238.42. If I click on any of these websites, this will also tell me what my ISP is. So right now I'm from Andhra Pradesh, and the ISP that I'm using is Beam Telecom, Act 500. Okay. And now, if you want to check your private IP on the other hand, the IP that I'm getting for this device, the laptop, you can just go to your command prompt, cmd, and in the command prompt, you can run a command ipconfig. And this shows me my private IP here. So right now I'm connected to my Wi-Fi network, and this is the private IP, 192.168.0.7. Okay, so that's how you check each of those IP addresses, guys, public and private. Okay, so yeah, again, a very short session, guys. Since this is the first class, we're going to end it up over here itself. All we have discussed is what IPv4 addresses look like, what are the types of IPv4 addresses, public and private, what is the range of IP addresses, what's the first IP, what's the last IP, and what are the sequence of IPs one by one. Okay, now one last thing. What I'm going to do is I want all your email addresses, guys. Please share them in the chat box so that I can share this notepad file and the recordings as well. Okay, so just drop your email in the chat here. Okay, and along with that, now you'll be getting the recordings after a while. I can please see to that there are no typos, guys.
Recording stopped.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've got 12 emails, I guess. I have 14 participants, which means one email is missing. Did I copy all the emails, guys, or did I miss out someone's email? Okay, got it. Perfect. Okay, guys, I've sent you the class notes. You'll be getting a recording as well, guys, shortly in a few minutes. I have to convert the recording first and then send it to you. I'll be sharing a link through an application called a web application called Wormhole. So this is a platform where you can share online files, again, of any size you want. Okay, but again, this link is only available for 24 hours, guys. So whatever, again, I don't want to save all the recordings on my drive, get filled up because I take a lot of classes every day. So I'll be sharing this platform, guys, Wormhole. Again, the link you get is only available for 24 hours. Please download that before 24 hours. Okay, or it will expire and I won't have the recording on my system as well. Okay, because I delete them on the go after I share it online. So again, I'll be sharing the recording in a bit. So please download it after you receive the link. Okay, that's it, guys. Nothing further for our session today. We'll join back tomorrow at the same time and we'll continue from where we exactly left off. Okay, Naz. Yeah, sure. Again, one important, yeah, good question. Naz, 1 second. If the session disconnects, please join back again. There's a 40-minute time limit. Okay. So there's only 1 minute left. So it just gets disconnected, it's joined back. One important point to note now is if it's a publicly hosted server, okay, if it is accessible on the internet, it always gets a public IP. Okay, if it is a private IP, I mean, if it's a local intranet device on the cloud, you're having an instance which is not accessible on the internet, but only in a local organization, it always gets a private IP. Okay, in an intranet, private. If it's public, it's, I mean, if it's on the internet, it's public IP. That is a very important point to note. So, Naz, can you hear me? Yeah, Naz, again. Yeah, please go ahead. Okay. Okay. Yeah. Okay. I don't get your point. Because again, in our home network also, if you notice a router, if you take a router as a device, it's an inter-networking device. It gets a public IP on one interface and a private IP. Right, exactly. Again, as I've mentioned, if it's a publicly available, what do you say, instance, okay, if it is having a domain or a subdomain which can be accessed from anywhere on the internet, from any place, it gets a public IP. But let's say it's just an internal device, okay, it is not being hosted on the internet, okay, it is not being published on the internet, it is just used in an intranet network, then it gets a private IP, even if it is hosted as an instance on the cloud. Mhm. Again, it's a server. That server will definitely get a public IP from the ISP. Internally, it will have a private IP as well. Now, if you take my device as well, now, so right now the laptop I'm using, it gets a public IP from the router. Okay, simultaneously to communicate in the local network, it has a private IP. Every device will have two IPs, public and private as well. Okay, on what interface you get it, that's different. Okay, right, sure. Again, guys, I'll be sharing the recording shortly in a bit. Okay, please download it within 24 hours. Okay. Right. Bye bye. I'll see you tomorrow, guys, at the same time. Good night. Good night, guys. Mm.
Good night to me. I love myself so much. I mean the world to me.
Yes. But I said yesterday. Oh my god. Oh my god. Oh my god. Oh my god. Holy shit. Oh my god. Oh my god. Oh my god. Oh my god. Holy shit.
He's back too.
Friend I can not see for years. Not really talked. Just like where we left off.
Totally agree. It's just easy.
Here's the other friend I can not see for years.
What advice would you give to your younger self?
Have more sex
So why'd you say that?
when you get old, like I am, on your deathbed, you're not going to be regretting having too much sex.
Yeah.
You're more likely to be regretting not having enough.
What advice would you give to your younger self?
Have more sex
So why'd you say that?
when you get old, like I am, on your deathbed, you're not going to be regretting having too much sex.
Yeah.
You're more likely to be regretting not having enough.
What advice would you give?
What do you want?
तुम्हारा कैसा है?
How much चाहिए? क्या चाहिए?
मेरा नंबर है ना?
किसका?
तुम्हारा
मेरा?
फोन नंबर?
ये देखो उधर क्या रहता?
मैं सुअर क्या? उधर देखता.
क्या बोला?
सुअर क्या औलाद बोला?
किसको?
तुम्हारा.
मेरी को सुअर क्या बोला?
चलो बेटा. ये 1.5 किलो का मुंह पे पड़ता हिसाब दिलाता.
पागल है.
जिंदगी नहीं मिलेगी दोबारा.
किसको?
ये भी तेरा